This is a video demo for the 10-core Flexus F2320 stress measurement system. This is the main housing you can see here. In the upper left hand corner is our temperature controller slash indicator. We have 3 switches, one for heater, one for fan. We have the laser on and off, and actually there's a 4th switch, the main. Over here we have the computer. This system runs DOS version 5.0. Inside the unit we have our hot plate and air circulation for cooling. And up here there is a shutter button which will only allow laser to come through if the door is closed. Keep that in mind. And now we will start the computer. And let the computer boot up to the system. Here we go, the Flexus Stress Measurement System version 2.0. Okay, now that the software is loaded, I've placed a calibration wafer flat into the system onto the hot plate. Now we are ready to begin the process. Select stress measurement from the window. And first film, we'll go with vid test. Enter that, and it'll measure the flat mirror. It'll then display a graph of the information that it collected, along with a summary, which tells us our radius and our bow. Press enter again. It'll give us a graph of our light intensity over the distance of the wafer. And we'll return back to the screen and it'll give us a summary. And we will get out of here. I've now placed a curved mirror, which should measure 20.4 in the area of that, onto the hot plate. We will do single stress. Vid test's already in there because it's the last one we did. Just put some information in there, and it will now measure and calculate the radius, curvature, and stress. And you can see that the radius is 20.443. Our spec is 20.40 plus or minus 2.5%. So that is well within spec. It shows a bow of 38.93 micrometers, and stress is 665.7 megapascals tensile. Go ahead and hit enter. We will get a graph of the light intensity as before. And then finally we get a summary of the information here in red. Use escape to get back to the main part. Now a wafer has been placed on the hot plate, and we will demonstrate the temperature over time process. So the first thing you're going to need to do is you will need, as with any of these measurements, to do a first no film measurement. So we'll do heat test. Give it the rudimentary ID 001. And we will perform the first measurement. Once again, the information will be displayed. Now we go down to stress temperature. So we'll fill in the information as we did before. This time we're going to hit create recipe because we don't have a recipe in there. So as you can see, a screen popped up on the right. Basically going to make as many steps as you need to, up to 15 it seems, and it will calculate the ramp rate and based on the temperature you put in and the time for each step. And then the readings, it'll take them incrementally depending on how many you put in. So we'll put 100 in here for now, just so we could see the system operating. We'll put that in for 45 minutes. We'll take 2 readings for this step, and if you hit enter, it calculates the ramp rate as 1.73 degrees per minute. When you're finished, step 2, save changes, eat, E-I-D. Note you're not obligated to use all the steps. Now note it says furnace stabilization delay controller set at, and the degrees are going up. You'll also see over here on the furnace temperature controller, the temperature is being ramped up slowly, as per the bottom being the control set point and the top being the output. It will, when it reaches the target, slow down and the temperature will ramp up slowly. Inside the machine, the wafer is on the susceptor and it'll be heating slowly to the temperature requested. Note, after it reached the temperature that was already there, it began with a measurement. On the screen, you'll see 1 point. The next reading is in 22 minutes and 15 seconds. Session ends in 44:40. So I asked for 2 measurements, and it is going to do the next one in 22 minutes, and then the session will end in 44, exactly double the time. Displays the temperature measured, and you can see there's a scale. As the temperature rises, the plot will go whatever way need be to indicate the proper data.